All right, so this is our video on adding and subtracting fractions. You've added and subtracted fractions before. This should not be a big deal. But we don't want to go any further without making sure that you don't feel comfortable with it. You do feel comfortable with it, I mean. All right, so remember, to add or subtract two fractions, they have to have a common denominator. Ideally, the lowest common denominator, so that we might not have to simplify. Okay, so looking at these two numbers right here, we need the lowest common denominator. Now, I could get just a common denominator by saying 6 times 3 is 18. A common denominator would be 18. But the lowest common denominator is 6. 6 is already 6, and I can get a 3 to be a 6 by multiplying it by 2. So I can't just multiply the denominator by 2. That changes the value. But I could also multiply the numerator by 2, and 2 over 2 is 1, so I'm not actually changing the value by multiplying this by 1. Okay, so now once you do that, this is the way I do it. I say, okay, so this is 6 and that's 6. So I have my common denominator, so I write it down once. I don't write down brand new fractions. This numerator is 5. This is plus, so I write down plus. 1 times 2 is 2. Now clean up your numerator. 5 plus 2, 7. So your answer is 7 6. I gotta undo that. Okay, I don't like that. Oh my goodness, that's not gonna be okay. Ready, watch, I'll fix it now because I'm not gonna move on without fixing it. How do I do no fill? All right, thank you. Okay, I'm glad I talked myself through that. I'm not starting my video over. Okay, some teachers teach it after this step. They say, so like prior to this step, they say, okay, so now I have, this is 6 over 5, that didn't change, plus 3 times 2 is 6, 1 times 2 is 2, and then they go to this step. I don't do that because I find that some students will look at this and they'll say, oh, I got to simplify that. That's 1/3. And then they're going backwards, all right? So I automatically jump to the next step. Okay, I don't like the way my key looks, so let's get rid of that to make it look pretty for when I send it as a key. Voila, okay. All right, this one right here, I need the lowest common denominator. Once again, I could do 6 times 15 to get a common denominator, but I need the lowest, I want the lowest, right? So a trick that I use is that if it doesn't pop into your head, take the bigger of the two denominators, which is 15, and ask if that's your LCD, right? It's not, because 6 isn't, I can't get a 6 to be a 15. So then you take that 15, that bigger denominator, and double it. See if that works. If not, triple it, and then quadruple it, because that I find is the easiest way for students to do it. So if I take 15 and double, it's 30, and 6 is a factor of 30. So I can I can get both my denominators to be 30. To get this to be a 30, I'd multiply by 2. But what I do to the denominator, I have to do the numerator. To get this to be a 30, I'd have to multiply by 5. So now I know that I have my common denominator of 30 for both. Right? You see how I do that? I automatically write it. Instead of writing 25/30 minus 8/30. I say I have 30 for both, and then I do 5 times 5 is 25. This is a minus. 4 times 2 is 8, and then I simplify. 25 minus 8 is 17/30. And then if that fraction was simplifiable, you would simplify it, but this is not. All right, so next we have fractions that have x in them. Not a big deal. We're going to start by finding our LCD still, okay? One of them is a number, and one of them is x plus 3, right? So we need something to cover that x plus 3, so we definitely need an x plus 3. But then we also need a factor of 7, right? So the fastest way to do this one is just to say, oh yeah, I need a 7, I need an x plus 3, 7 times x plus 3. Do not ever distribute these. Don't make it, expand it, because that's not going to be helpful. All right, so you want your common denominator to be 7 times x plus 3. So this already has a 7, so I'm going to need to multiply this one by x plus 3. But what I do to the denominator, I must do the numerator. And then this one already has the x plus 3. It still needs the 7. Okay? So now I'm going to write my common denominator. This is how I do it. 7 times x plus 3. And now I'm going to write my new numerator. What's my new numerator? This jazz right here. Okay? I'm going to put the x minus 2 in parentheses so I don't, lose the x. All right, so 7 times 3 is 21. Then I have a plus sign, so plus. And then I have these two being multiplied. So I can write down x minus 2 times x plus 3, but they need to be multiplied. So I'm going to multiply them out. X times x is x squared. Outer is 3x, inner is negative 2x, that's plus x. And then last is minus 6. This numerator is not cleaned up, so we do want to clean it up and write it in standard form. So x squared first, then plus x. 21 and negative 6 is plus 15. And then that's all over 7 times x plus 3. Okay? Now we do have to see if we can simplify this. You can only cancel out, I'm air quoting and you can't see me, but you can only simplify to 1. We say cancel out terribly, but cancel out. Common factors from the numerator to the denominator. If you look, the denominator is factored 7 times an x plus 3. The numerator is not factored. We can check to see if it's factorable. But if you look at it, to factor this, I would need two numbers that multiply to give me 15 and add to give me 1. That's not factorable. If that's not factorable, then there are no factors other than the entire trinomial itself, so nothing is going to cancel out. This is it. That's all you can do. All right, go ahead and pause the video and try 1 through 3 on your own and see how you did. You could also see why my box was filled in instead of empty. Okay, so here we go. You can check your answers. The common denominator for number 1 is, the least common denominator is 35, which happens to be 7 times 5, and you get 29 35ths. The least common denominator for number 2 is 3. The number 2 is 2 over 1, and so you had to multiply it by 3 over 3, and you get x minus 6 over 3. Please remember on this that you can't go boom, boom, and say, oh, that's 2x minus 2. No, that's not how it works. You can only cancel out common factors. This is a factor of x minus 6. There is no x minus 6 in the denominator to cancel with it. All right, also it asks for any domain. Oh, I forgot about this one. Here we go. Okay, so this one, x plus y over xy. And then there's also these domain restrictions. X can't be 0, y can't be 0. X can't be 0, y can't be 0. Let's talk about those domain restrictions. Remember what a domain restriction when we have a fraction looks like. We know that we can't divide by 0. So any x value or whatever, any variable value that would make the denominator 0 is not going to be something that we want to work with. If you look at this problem, there's no x's in it, let alone x's in the denominator. This one has an x in it, but it's not in the denominator, so there's not going to be any restrictions. This has an x and a y in the denominator. So I said x can't be 0 and y can't be 0 because if they were, you would get a 0 in the denominator. All right, let's go ahead and try the next 3 here. So if you look at what your LCD is, your least common denominator, we need an x plus 5 to cover that x plus 5. But then we also need an x to cover that x. The x in this x plus 5 does not cover that x. It's not an x. It's an x plus 5. Okay? All right, so that is my LCD. So I'll multiply this by x plus 5 over x plus 5. And this, we're multiplying. I'm going to put it in parentheses. Multiply this by x, multiply this by x. Write your new denominator. That is x times x plus 5, right? And then my new numerator is everything that's here. So I have 4 times x, which is 4x. I'm going to distribute this negative 7. That's minus 7x minus 35. And then I'll combine like terms in the numerator. 4x and negative 7x is negative 3x minus 35 all over x times x plus 5. Once again, I want to see if this is simplifiable, because if it is simplifiable, I want to simplify it. The denominator is already factored. The numerator is not. So I look at it and I say, ooh, is there a GCF or something? Because it'd be nice if there was an x plus 5 that canceled with an x plus 5. But there isn't, right? There's a GCF, I guess that you can say that there's a factor of -1, but that's not helpful. All right, so that's your final answer. And then there are restrictions on this because I do see x's in my denominator. So I know that x can't be 0, right? Because that would make this 0 times something. And then x can't be -5. X can't be negative 5 because that would then become an X, or sorry, negative 5 plus 5, which is 0. So there's your domain restrictions. Or sorry, there's your restrictions on X. All right, this one here, if you want to pause and try it yourself and see how you did, your LCD is X minus 1 times X plus 3. Oh, that's not good handwriting. What's going on there? Okay, so I need to multiply by X minus 1, X minus 1. And this one times X plus 3, X plus 3. All right, my new fraction, so my denominator, X minus 1 times X plus 3. It doesn't matter which one you write first and which one you write second. Like X plus 3 can be first. It doesn't matter. And then my new numerator is all this jazz. Okay, so I have X times X plus 3, which I'm going to distribute that X squared plus 3X. And then don't forget that this is a negative 2 times these. So minus 2X plus 2. Combine like terms and write your new numerator. So this is X minus 1 times X plus 3 in my denominator. My new numerator, X squared plus X plus 2. Look to see if your numerator is factorable, because if it is factorable, and let's say an X plus 3 and an X plus 3 cancel, or an X minus 1 and an X minus 1 cancel, it'd be simplifiable, but we don't know two numbers that multiply to give us 2 and add to give us 1. Okay, unless I, distributed wrong, or I, combined like terms wrong, which I don't know because I'm not comparing this answer key with anyone else. So fingers crossed. Okay, last one in this section here, we need to find our LCD. So in order to see your LCD, like when you have X's in your denominator should be factored. And if you look, our second denominator isn't factorable, but our first denominator is factorable. So what I'm going to do is I'm going to factor it to X plus 2, X minus 2. And then I'm going to cross this off like it was never here, because they're equivalent and the factored form is much better. All right, so now I need an LCD. Okay, so I need an X plus 2, right, to cover my X plus 2 in each fraction, but I only need one of them because it's already there. But then I also need that X minus 2 to cover the X minus 2. And if you look, I can get both denominators to be X plus 2 times X minus 2. The first one already is. The second one is just missing the X minus 2 factor. So I'm going to multiply the second one by X minus 2 over X minus 2. The first one, already done. All right, so my new denominator, X plus 2 times X minus 2. My new numerator, we have that 5. It's a plus. If it was a minus, I would say like, oh yeah, I'm going to write this next part in parentheses so I can distribute the negative, but it's not. All right, multiply this out. X times X is X squared. Outer's negative 2X, inner's negative 3X. That's negative 5X. Negative 3 times negative 2 is positive 6. Clean up your numerator. Your denominator is good. And if people will always ask, like, should we multiply that out? No need to. If it's simplifiable, it'll make it worse. So just leave it. All right, so we have X squared minus 5X plus 11. See if your numerator is factorable. It's not. Two numbers that multiply to give me 11 and add to give me negative 5. So this is my final answer. All right, I forgot about restrictions on the last one now that I got to this. So if I look at this one, I have two restrictions. X can't be negative 2 and it can't be positive 2. So I'm just going to write positive negative 2 like that, because if it was that, then this fraction wouldn't exist, or it would be undefined. And on this last one right here, X can't be 1 and X can't be negative 3. Okay. All right, this next section, there's 6 problems here. It is not, look at the difference between the two, okay? The first half was adding and subtracting fractions. This is solving, and it has fractions in it, okay? I could teach it to you the exact same way as the other way, as what we just did, but I'm going to teach it to you the way that I prefer because I think it's better. Shocking, I know, right? So I'll show it to you doing it the exact same way as what we just did, but then I'll show you my air quote shortcut on how I do it, and then you decide. It's up to you. I don't care. Okay? All right, so let's not pretend. Let's do it the exact same way that we did the other problems first. Okay? So first off, I need my LCD. I have a 6, a 5, and a 1. So for a 6, 5, and 1, the lowest common denominator is 30. So I'm going to get them all to be a 30. So this one I'd multiply by 30 over 30. This one I'd multiply by 6 over 6. This one I'd multiply by 5 over 5. Okay, so now I'm going to get my common denominator on this side is 30. And then I have, this is the new numerator, so I'm going to multiply that out. 5 times 2x is 10x. 5 times 5 is 25. Plus, distribute your 6 here. So 6 times x is 6x. Negative 1 times 6 is negative 6. And then I have equals. 4 times 30 is 120. And 1 times 30 is 30. Okay? All right, so the next step you can do is that you can get rid of the 30s in the denominator. They should always be the same. But if you think about it, it's like, ew, I hate that there's a fraction. Well, guess what? The denominator is 30 on both, and we can do whatever we want to both sides of the equations as long as we do it to both sides. So if I multiply the left-hand side by 30 and multiply the right-hand side by 30, so like times 30, right? Then these 30s cancel out, and you just have to solve that equation right there, right? The 10x, let's combine like terms. 16x plus 19 equals 120, and then subtract 19, which is 111, or sorry, 101, right? 101, 16x, and then divide by 16, and you get 101 divided by 16, okay? So that's the answer, but I'm going to show you how I do it instead, okay? So do you remember how I multiply both sides of the equation by 30 to get the denominators to go away? I do that right away. I get rid of the fraction right away. It's just like my personal preference. So I'm going to erase this, and I'm going to say, what's the LCD? And I only can do this with equations, okay? You're solving an equation. You can do whatever you want to both sides of the equation as long as it's the same thing. So I'm going to say, okay, I hate that there's fractions. I'm going to make it so they're gone. So what do I need to do to get rid of the fractions? I need to multiply both sides by the LCD. The LCD is 30, okay? So I'm going to multiply both sides of the equation by 30. So this times 30, there's your 120. And then I'm going to multiply this side by 30. And when I multiply this side by 30, I have to distribute the 30 to each of those fractions. So what I do is I just say, okay, I'm going to multiply this fraction by 30. I'm going to multiply this fraction by 30. And then I simplify these fractions right away. So I say, okay, 6 goes into itself once, 6 goes into here 5 times, 5 goes into here once, 5 goes into here 6 times, and now I write down what I have left. So I have this left, right? The denominators are already gone. I just like it better. So I'm going to distribute the 5. I got 10x plus 25, and then distribute your positive 6, so plus 6x minus 6 is equal to 120. Combine like terms on the left-hand side, that's 16x plus 19 is equal to 120. Subtract 19 from both sides. 16x is equal to 101, and then divide by 16. And you have x is equal to 101 over 16. Oops, 101 over 16, which is not simplifiable. So you're just going to leave it like that. Okay. Also, we would have to check to see if this made our denominator 0, and there's no x's in your denominator, so you don't have to worry about it. But that's how I'm going to do it if everyone's okay with that. Okay, so instead of getting an LCD, I'm going to find the LCD and get all my denominators to cancel out, go away. Okay. All right, so keeping in mind that's how I'm going to do this. The LCD for this equation is x plus 2, because this is a 1 right here, right? So it's x plus 2, so if I multiply every single term, both sides of the equation by x plus 2. So x plus 2 here, x plus 2 here, x plus 2 here, okay? Simplify your fractions. If you did this properly, all of the denominators will cancel. This x plus 2 and this x plus 2 cancel. This x plus 2 and this x plus 2 cancel. And now you're going to write down what you have left. So I have the 3. I have this minus 1 times x plus 2, so I'm going to distribute that. So minus x minus 2 is equal to 7. So that's negative x plus 1 is equal to 7. Subtract 7 from both sides, negative x is equal to 6, and then divide by negative 1, you have x is equal to negative 6. Check to see if that is going to give you a 0 in your denominator. If you look, if I plug in negative 6 here or here, you don't get a 0 in your denominator. If I would have gotten negative 2 as a solution, that would have been bad, because then I would get undefined fractions, and that's not okay. All right, moving on to the next one. I need my LCD first, but this one's not factored, so let's go ahead and factor it. That's x plus 3 times x minus 3. All right, so my LCD, obviously I need an x plus 3 times x minus 3. Right? And then the x plus 3 is covered here, and the x minus 3 is covered here. And remember, you're just trying to say if I multiply everything by this, will the denominators cancel? And the answer is yes. So I'm going to multiply everything, both sides of the equation, by x plus 3 times x minus 3. X plus 3 times x minus 3. X plus 3 times x minus 3. And if this is the correct LCD, then all the denominators will cancel. So this factor and this factor cancel, this one and this one, this one and this one, this one and this one. So now you're going to write down what you have left. So you have 8 times x plus 3. Well, actually, I'm just going to distribute now instead of writing that down and save ourselves a step, right? I have 8x plus 24. Plus distribute your 2 plus 2x minus 6 is equal to 4. Combine like terms, that's 10x plus 18 is equal to 4. Subtract 18 from both sides. That's 10x is equal to negative 14. And then divide by 10. And you have x is equal to, those are both even, so I'm going to simplify it by dividing by 2, negative 7/5. I hope I didn't make a mistake there. I could always check it by putting in my calculator and seeing if it's right, but I'm just going to look at my mental math really quickly because I don't have an answer key to compare it with. 3x plus 24, that's right. X plus 3 cancels. 2x minus 6, that's right. Those cancel, that's cancel. That's 4. It looks good to me. 10x, 18. Minus 4, 14, good. Okay. All right, why don't you pause the video and try this one on your own, these 3 on your own, see how you do, okay? And then what you can do is you can go to the answer key that's in Schoology and check your answers, compare to them, and see how you did. Okay.